In Berlin, they are building a new airport called Flughafen Berlin-Brandenburg, or short BER. Originally, the first planes should have taken off in November 2011, but since today no airplane has started or landed at this airport and the costs are growing and growing. Besides all the problems with the constructions, there is one more big question. Is it really necessary to build a new big airport at this location? Berlin already has two international airports, Berlin-Tegel and Berlin-Schönefeld, and there are a lot of people who doubt about the location of the new airport for several reasons. I will focus on BER as a potential international hub for passengers and cargo. I want to find the optimized location for a new hub airport considering the data from the biggest already existing airports in Germany, Europe and worldwide and compare it to the actual location of BER. First, we have to think about calculating distances. In a two-dimensional space, the distance between 2 points A and B is calculated by the distance function d. In our case, I want to take the importance of the individual airports in the fields of number of passengers and masses of cargo into account by using weights. These are simply the percentages of the total number of passengers or cargo of each airport. So we use a weighted distance function for calculating the individual distances between each airport and the optimized location. Our goal is now to minimize the sum of all individual weighted distances for a total number of n airports. For minimizing line 3, we have to transform the function into line 4. What we are doing is to change from the sum of distances into the sum of squared distances. This won't lead to the same results for the distance, but the optimized values x and y will be the same. This step is necessary because we will need the derivations to find the optimized values, so f is differentiable on R, but Vd is not. The next steps are just some transformation of f to make the derivation easier. As a result, you can see that we have now splitted f into two functions with each only one variable. The reason is that calculating the minimum is now much easier. So now we can focus on each of the two functions and derive them separately to find the optimized values. I show the calculation for x. After transforming the function, the next steps are the first and the second derivations. First, we focus on the second derivation. Because the sum of all individual weights equals 1, our second derivation is always bigger than 0. This proves that our result will be a minimum. So now we can focus on the first derivation and solve it for the optimized x. So first, the derivation has to equal 0. After transforming the equation, we get this. As we already know, the sum of all weights equals 1, so we can even simplify our equation. To get our optimized result for y, we just can take the equation from line 8 and repeat all the steps 10 to 18. As you can see, the optimized results for x and y are just the sum of the weighted individual x's and y's. As we now have a way to calculate results, we can use data from the real world and check where the best location for a new hub airport is. As the calculation is quite easy, I decided to calculate with data from Germany, Europe and worldwide for passengers and for cargo. As there is no data for the biggest cargo airports in Europe, I had to skip this part. For Germany, I considered only the biggest 10 airports. For Europe and worldwide, I took the biggest 30 airports to get better results. As the world is not a mathematical two-dimensional coordinate system, x and y are now longitude and latitude of the geographical decimal coordinates of the airports. The distances between the optimized new hub airport and BER are also calculated by the improved function for distances between geographical coordinates. On the following maps you can find blue dots which show the existing airports, a black dot, which shows the location of BER, and a red dot, which shows the perfect location for a new hub airport for each dataset. Let's start with the top 10 passenger airports in Germany. As you can see, the perfect spot for a new passenger hub airport would be located very central in Germany, about 15 kilometers east of Fulda. This location is about 300 kilometers away from BER. Meanwhile, Frankfurt Airport, as Germany's biggest airport, is located only around 110 kilometers away. Even 6 other of the biggest German airports are closer located than BER. If we calculate the optimized results for the top 30 passenger airports in Europe, we get a spot about 30 kilometers west of Stuttgart in Germany. The distance to BER is more than 525 kilometers, and there are several big airports much closer, like Frankfurt, Zurich or Munich, and 6 more airports. For worldwide top 30 passenger data, we get the following spot. The perfect location for a new hub airport would be about 5 kilometers off the Libyan coast, around 60 kilometers northeast of Benghazi. The distance to BER is more than 2,250 kilometers away. The nearest airports are Istanbul, Barcelona, and Frankfurt. So let's change to cargo and start with the top 10 cargo airports in Germany. As the map shows, the optimized spot for a new cargo hub airport would be located 25 kilometers southwest of Fulda. BER is located more than 350 kilometers away, and nearly every big German cargo airport is closer. First of all, Frankfurt, as by far biggest German cargo airport, which is located not even 75 kilometers away. If we check the data for the 30 biggest cargo airports worldwide, we get an optimized spot for a new international cargo hub airport about 80 kilometers southeast of the Greek island Creta. Even though only the German airport Leipzig-Halle is closer to the spot than BER, which is located about 2,250 kilometers away, big European airports like Frankfurt, Paris or Amsterdam, or the Arabian airports Doha and Abu Dhabi are located with nearly the same distance. After all the calculation and the maps, what is my result? I have shown that it is not that hard to find optimized spot via minimizing the sum of weighted distances to existing locations. By transforming the function, you get a formula which proves that you can just sum up the weighted coordinates if the sum of the weights equals 1. This makes the calculation fast and easy, because you could calculate by just using tables like Excel. When it comes to the appliance of my formula, I have shown that for nearly every optimized spot for a new hub airport, there are several existing big airports which are located much closer than the location of Flughafen Berlin-Brandenburg. Only in the field of international cargo airports, BER was nearly the closest airport. But like I have shown, that several big airports have the same distance to this spot. Furthermore, it would be easier and cheaper to expand the big passenger airports Istanbul or Athens, which are located only around 750 kilometers or 480 kilometers away, than building up a completely new airport. To answer my opening question, is there a better place for BER? Yes, it is. It depends on which business, passengers or cargo, in which part of the world, Germany, Europe or worldwide, you focus, but in each of these fields I have shown that the position of BER is not optimal located. Finally, I found an interesting side fact. If you take a closer look on the locations of the biggest 30 airports in the world, passengers and cargo, you can see that there's only one airport located in the southern hemisphere. This is Soekarno-Hatta International Airport in Indonesia, which is number 17 in the list of the biggest passenger airports worldwide. And even this airport is located only about 660 kilometers south of the equator. This fact shows again how much bigger the population and the economy of the northern hemisphere is compared to the southern part of our world.